Today we are looking at lesson 3, using technology to display data and find a linear regression equation. So 2 goals are to develop a linear regression equations from a table of data and to use the regression equation to solve problems. In a nutshell, we'll be using either a graphing calculator, which is a TI-84, 83, or Desmos, which is online. And what we will be doing is that we're using this technology to interpret the data. Be given a set of data. And from this set of data, we'll develop an equation, which is the line of best fit. So we'll end up with the line of best fit. This line, the equation for the line of best fit, is called a regression equation. So a regression equation is basically an equation that shows a relationship between 2 variables, between 2 things. Now, there are many types of regression equation. The one we are focusing on right now is a linear regression, meaning it's a straight line. There are other kinds of regression equations, such as quadratic, which is a nonlinear, it doesn't go in a straight line, or a cubic. But for this lesson, we're looking at a linear regression, a straight line equation, which shows a relationship between 2 variables. And it's mainly used to predict values within the range, predict values within the range, or which we call interpolate. Here's all the values within this range, this given range. If we go beyond the given range, we call extrapolate. And that's what we use for prediction. So finding equations, these equations here, they're called mathematical modeling. And they're using physics and earth science, artificial intelligence, economics, etc. So when we have a regression equation, such as this one here, we can use it to predict additional values that are not in the table, which we call extrapolate. So we can extrapolate, or we can interpolate. So within here is called interpolation. When we go beyond it, it's called extrapolation. So in today's lesson, you'll be given a set of data. We will put that set of data into our calculator. And then our calculator will develop the linear regression equation. Then we sketch that graph on our workbook. And then we'll ask certain questions regarding prediction or interpolation, extrapolation or interpolation. So we'll be looking at a few questions today. It will take some while. And we'll be using the trusted graphing calculator here. Oops. Or we'll use Desmos. We'll have the same result. Now, if you don't have a graphing calculator and you haven't been able to install it on your phone, or you don't have a computer, then you can use Desmos easily. Let's look at the first question. We're asked to determine the linear regression equation that models this situation. Now, here we're given a set of data in a table. And we're asked to find a linear regression. But what I'll do today for the first thing is to construct the line of best fit on this graph paper here. Then I'll show you how to use the graphing calculator or Desmos to find the linear regression equation. I will not be able to find it accurately using my graph, but I'll use it more accurately using the graphing calculator or Desmos. Okay. Either one will give us the same result. So look at our data. Here we have size in square feet and the prices. Now, these are prices for houses. We're looking at the size of houses. So here we have, you want to scatter plot, we have the size of a house. So here we have the house size. And here with the price. This will be our x-axis. This will be our y-axis. In our calculator, this will be L1 and this will be L2. So you want to transfer this set of data on our graph. Now, our x-axis we know is house, so we call this house size. And it's in square feet. Now this goes up. The minimum here is 1,150 and the maximum 2,490. So our minimum on our x-axis should be 2,490. So approximately 2,500. So we want to make our scale in such a way it will go beyond 2,400. Here you have a grid out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can make each one of these 500. So if you make this a 0 here, this would be 500, 1,000, 1,500, 2,000, 2,500, 3,000. So we'll go beyond it. So this is going to be 500. Be 1,000, 1,100. I'll just make this a bit lower. $1,500, so give us 2,000, 2,500, 3,000, 3,500, 4,000, 4,500, and 5,000. So my scale equal increment of 500 square feet. My y-axis will be the price for the houses. So I'll make these into thousands because its scale is going up by 100,000. So I can make this as the price And 3 zeros there, meaning that whatever I have here, I add 3 zeros to it. So I have 100, 200,000, 300,000, 400,000, 500,000, 700,000, and this will be a million or a 1,000,000. Next, I'll plot these points on the graph. So at the 1150 is 268,000. So 1150, 1,100, it's around approximately here. So I'll use my ruler to get a better estimate. And this goes up to 268,000. Now this is 200,000, 300,000, approximately 250,000 here. So slightly above it, so it will be about here. So that's my first point. Next one is 1380 at 265. So 1380 will be about here. And this 265,000, so, which is slightly below it. So this. So 1380, the price slightly below. So then 1568, it should be just above 1500. And that's 349,000, which is slightly above 350. Then 1950, which is just for 2,000. This is 2,000. Just slightly above it. So that will make it 440,000. So 400 here. So just above, just below 450,000. And the final one is 2490. Just a point. This is not 1950. This 1950 would be here. Okay. So 1950, 440,000, which is and the last one is 2490. And that was close to 500,000, which is right around here. Now, what I'll do, I'll construct a line of best fit. So I'll draw a line that will go through most of the points. Now, if I want to go beyond this here, because this is my data, given data here, connect these points. Now I'll extrapolate that. In other words, I'll extrapolate it by not a solid line, but this means I'm extrapolating it. So this is my given set of data, so I interpolate, and this here by extrapolating. Now that's my sketch, but it's difficult to determine the equation. Now you can determine it using the equation of a straight line, finding the y-intercept and then the slope. But because it's applied math, we will use our graphing calculator to find our linear regression. And this is where you will use or instructions that you have. There's also a set of instructions in your booklet on how to determine the linear regression using their graphing calculator. Now, if you go to your booklet, and it's on page 13, this page has step-by-step instruction on how to derive or get your linear regression equation. So here's an example, and you can work it through with your graphing calculator, 284. But we'll go ahead and use the same set of rules to find the linear regression here. Also, you have this specific sheet here. I'll just zoom out so you can see it. Now, you have this handout, and it has the instructions on how to determine your regression equation. Here, you start off with entering your data in your list, sort your snapshot on, use your window, and you'll determine your equation. So we will follow this set of steps to help us to determine the regression equation. But we will be using this set, which is the same, but this is a more graphical format here. You can see the step-by-step here, but it's the exact thing. Okay, so I'll walk you through using the graphing calculator. So we follow this step here. Now, instead of using, we'll be using this set of data here. Okay. Okay, step one, you mentioned you press your stat button. So we'll go on and I'll move this up a bit higher so you can see the big picture. So when you press your stat button and edit one, you'll see a screen of this example here. But so press step one, press your stat button, and enter. Now I have a set of data in here. I need to delete a set of data so I can input a new set of data. Or you can simply type over it. But I'll show you how to delete all of these data here. So use the right arrow key and move up to L1 and press clear. Do not press delete. Press clear button here. Press clear and then enter. So to repeat, removing the data in L2, I toggle over to my right arrow button here. Then I move up. Then I press my clear button again. So press the clear button and then enter. So let's repeat the process now. So first step in creating your, or arriving at your linear regression equation. Let's quit here. Press your Start button. Then press your Enter button. Here we have a few columns, L1, L2, L3, L4, all the way. L1 will be referred to as our X coordinate points, and L2 will be the Y coordinate points. So once you have that, enter your data in the X value for L1 and L2. So I'll go ahead and enter the set of data. So just the first line, make sure you have your line correctly. You can go from left to right for each one, or you can do the entire, enter the entire data from this column into your calculator, and then move on to the next column and enter the set of data into the second column. I'll do the first column first, which is 1150. And I press enter. You have to press your enter button each time. The next is 1380. Next 1568. 1950. Next is 2490. Now I want to go on to the next, go into the next column. I press my right arrow button. Then I move over. Then I continue the same process, 268,000. Press enter. 265, 500, 349,000. 440,000. And 499,950. There you have a set of data. Enter. And that's step one. Step two, after entering your data, press the Start button again, and then press the right arrow key to highlight the Calc menu. From the menu picture, choose for linear regression. We are not doing quadratic regression yet. We'll do that later on. That's a different kind of regression. Quadratic is one where you have a curve bending. Linear regression, you have a straight line. So they're going up, going down, etc. So we're not doing quadratic yet. We're doing linear regression. So we'll go to number 4. So we'll follow the steps here. Step 2. So I'll press the Start button again. Then I'll go to Calc. Press the right arrow key and move to Calc. It's important for you to follow these steps. So do it again. We have this is our data in here. Then we press your Calc button, your Start button, go to Calc. Now, this other part, now we want a linear regression. So we want to go to number 4, right? So you can either toggle down to 4, or you can press 4. Either way. Now, press 4, we end up with this screen here. Now, once you've chosen the appropriate function, use the down arrow key, you will end up with this here, as I showed you here. now we're on to step 3. Now, it's L1, L2. We're not going to look at the frequency listing. Store EQ now. It says here, use your down arrow to move your cursor to the line that says store REQ. So we're going to go down to here. So it's highlighted here. We're going to move down. Now, once it's stopped there, you want to go any further yet, because this step is very important. Once you have there your picture, you're going to go to step 4. And at step 4, it says, once you get here, press the vars button and then use the right arrow to highlight the Y vars menu. So we press, and here is your vars button. It's to the left of the clear button. So press the vars button. And then use your right arrow to highlight the Y vars. So here's the Y vars. Once I move over to Y vars, I should see this window. So I'll move over to my Y vars, and it works out exactly as it is here. Now, once you have that, it's next step. So we have completed step 4. Step 5, press enter twice to select option 1 function, and again to select Y1. So now once we have, here we have it here. And so now what we will do, let's get it here. Oops. So you can see what I'm doing here. So press enter twice, once, twice. By doing that, that Y1 that I had for on the stats, on the vars, will appear here. What the calculator is now doing is to take that equation from the regression and put it into your Y equal button. So let's go back here again. So let's go to stat calc. I'll go back again. So here we have your stat. Initially, we have this as our data. Put it over again. And we back to step 3. We press our stat button, go to calc, and then we go to the number 4. Once you go to number 4, we want to go to store regression. Press your vars button, go to vars 1, and press this twice. Then I continue. You continue to press enter, enter, and enter. And there is your equation. Oops, sorry, missed that piece. I'll repeat that because I was off the screen here. Let me repeat that process again. Here's my, once I have my linear regression, I go to store EQ, press the vars button, and I press vars twice. Have it. Now you want to press your enter button 2 times. 1, 2. And this is your linear regression equation. Y is equal to 191.84 x plus 36,902. Now, these values here, you may not see it in your calculator because a feature may not have been turned on. It's called diagnostic. This tells you the correlation coefficient, how much these two sets of data are in alignment. As you can see from this, the R is 0.96. The closer it is to 1, the greater the positive correlation. If it's negative, it's the decreasing. If it's positive, it means it's an increasing trend. From our graph, we know it is increasing. If you look at our graph we sketched here, we know it's increasing. Now, that's our equation. We follow the steps, so we are here. But yet we haven't arrived at the graph we constructed. We have our set of data, which is similar to this one here. Okay, so here we have, which actually is the same set of data we have here. So now, I need to go to my y equal button here, and that will show me my full equation. Just that, and there is my full equation. Now, yet I haven't seen this graph yet. You wonder, where is it? It is in the calculator, but I'll show you how to. Now, we've entered a set of data. We have our equation. Now, this is a regression equation. So we'll write that down here. So our regression equation is y is equal to 191. Now it's a whole set of decimal places here. We'll go to 2 decimal places. 191 decimal 84. And notice here it's an x there. So we put an x plus, now I use my right arrow key here. It says here 36,902. 36,902 decimal 00. I can stop there. Now this is an equation of a straight line, or a linear regression. So that's how you arrive at your linear regression. Okay. Now, to see your graph, we can go to press the graph button here. But notice you see nothing. Okay, let's go back to our graph here. I'm not seeing anything here. And this is where you need to adjust your window. Okay, so press to adjust your window setting. Now notice what happens here. Look at my graph here. It's from 0 to 50. This was 5,000. So my x is from 0 to 5,000, and my y-axis is from 0 to 1,000,000. Now, if we go back to this sheet here, to go to your window setting. So I'm going to go to my window setting. My x minimum, now I'll go back to my sketch here, set of data. My minimum on my x is 0, so I leave it as 0. My maximum for my x is 5,000. So I'll move down to the x maximum and enter 5,000. Next, I want to go to my y maximum. Now, the ones you're looking at are x minimum, x maximum. Ignore the scale for now. We can change the scale later on. We look at what scale can do to the graph. But we'll go to x maximum and x minimum. Now we go to the y minimum, which is 0. In this case here, y minimum is 0. And your y maximum, remember this is 100,000, so this is 100,000, 200,000, from 0 to 1 million. So that'd be 1 million, 1, 1, 2, 3, 1, 2, 3. Now we have our scale. This graph, now notice it tells me here that there's an error. If that happens, I go back to my window. It means I did not enter the data correctly. So notice I have my minimum as 1 million, which is wrong. So I have my minimum should be 0. And if you make a mistake, the calculator will tell you there's an error. But I need my maximum to be 1 million. So now I have my maximum to be 1 million. My minimum is 0. My x maximum is 0. Oh, sorry, 5,000. And my minimum is 0. Now I should get my graph. As you can see, it's almost a duplicate of what we constructed on a graph paper. So it's a good practice to do a sketch on paper first with the data given for now. And that will give you your scale and your x minimum or y minimum and your x maximum or y maximum. And that you can put into your window so you'll be able to see your graph. Otherwise, it will be very difficult to see your graph because many times the data that's given here is way beyond the graph or your window here, like the one we just did, because this is very large values. Now, just a quick recap of what we did here. We have a set of data, and we like to input a set of data into our calculator and derive the linear regression equation that models the situation. We did a sketch on our graph paper here with our scale and labeling. And then we will go to our calculator, or graphing calculator here. The first step we took was to go to your stat button and press enter, and then we enter our data. Once our data is entered, we'll press our stat button again and go to calc and find our linear regression equation. Go down to linear regression. Next, we need to take that linear regression equation and store it, RQ. So I move down to RQ. Next, I press my vars button, go to Y vars, and press enter twice. Here I have that Y1. Basically, what will happen, this Y1 will go into this Y1 button here. It's already there. Vars. Now I move down and I press enter, and my equation is given, and it will appear in this line. This is your linear regression equation. You can also read it off from here. I go back here. This is your linear regression equation. Now you don't need the R. This just tells you the correlation coefficient, which we don't need to know right now. All what I want you to know is this is your linear regression model, y equal to ax plus b. The a is 191.84, and that's what we got here, 191.84. The b, then we have our x, you can put that x, the x is a constant there, and the b is 36,902.00. Into that. And this is your linear regression equation. To see our graph, we go to our window and we set our window according to our maximum for x and maximum for y, which we establish here, and we press the graph, and there our points are plotted. So these little squares here represent the data we entered here. Now we look at the next part. Use the regression equation to determine the price of a house that is 2,000 square feet. Now we can do an estimate on our graph here. Here the house is 2,000 square feet. We can say here's 2,000 square feet. So the price will be slightly above 420,000. I can estimate it. So we can do an estimation here at 420,000. So I can, for my account, $420,000. The price of a house. So that's an approximation. But that is just reading it off the graph. So I'll give you a good approximation, but let's define a better estimation. We go to our graph and calculate it. And these are the steps you want to take to get that. Now, the information is on the second page to determine the y value. Here we determine the y value when we know the x value. So I'll walk you through this and I'll show you the steps. Here, this is your x value. So the x is equal to 2,000. They ask you to find a y value. So these are the steps you will take. Now, when you're in your graph mode, you have to be in your graph mode and you have to have your graph there shown. And you have all your data input. So once you have your graph being displayed, the step you will take is second trace. So I'll write it down here for you, second button, and then I press my trace. You arrive on this screen here. Next, you want to press enter. So once we hit the trace, so let's go to it again. Here's my graph. Second button. Trace. Then I'll leave it at value. I'll press enter. So let's put that into here. Now, what is the x value? The x value is 2,000. So that's the question is asking, what is the x value? What is the y value when x is 2,000? Next, I'll enter 2,000. So x equal 2,000. So I'll put 2000 there. Then I'll press the enter key again. And you'll see the value of the y given slightly below it. And you can see the cursor flashing. That tells you that this point, x is 2000 and y is 420,584. So we have y is equal to 420,584. So we can say a house that is 2,000 square feet will have a price of 420,584 decimal $36. Now, all of those instructions are on this sheet up here. So you enter, here we have our enter equation. Enter per second, trace, press enter, type whatever x value you have, in this case was 2000. Then press enter again, and there you have your value. The next one, determine the price of a house that's 3,400 square feet. So here again, x is again given to you. So x is 3,400. Question is, what is y? We'll follow the same process again. We'll press second button, trace. And then we'll have press enter button again. And in this case, we'll have x is equal to 3,400. Enter. And we'll have our value. Let's see how will that show up as. So now per second, trace, enter, 3,400, press enter. It gives me a price of $689,162.01. So that's 600 and so y is equal to so the price of a house that is 3,400 square feet is $689,162.01. So we highlight these numbers here. So this is, just remember these steps here. You may want to keep this as a nice study sheet to use, but also the visual to do your line of best fit or linear regression is on this page here, and the example I've just worked out with you. So our goal so far was to develop a linear regression equation from a set of data. That was our goal. Here was a set of data, develop a set of from a set of data, develop a linear regression equation. That's what we did. Then the next step was to use a set of data to solve problems. The problem in this case, what is the price of a house of 2,000 square feet given our data? In this case, we were interpolate because we're given data for houses that are greater than 2,490, or we're greater than 2,000. The last part here, 3,400, we are extrapolating. So we are making prediction, saying the prediction if a house then, based on the data given here, that is 3,400 square feet, the price of that house will be 689,162. Now, this is an approximation, this is an estimate. And this is what linear regression or regression equations can help you to do, to make predictions. And one of the things it is assuming, it's assuming that what is happening in the past here will continue. Now, it's a big assumption, but one set of data doesn't necessarily predict the future. You need a whole set of data. The more data you have, the better is your prediction. But at this stage, we're just using sample to demonstrate what a linear regression equation looks like. Okay, it's a straight line, a set of data, and we use our graphing calculator. In the next lesson, I'll use Desmos to do the same thing. But if you have a graphing calculator, continue to use it and follow the steps on page 13. And every one of you should have a copy of the sheet here. If you don't have one, it's on the blog. You can print it out. Or if you need a hard copy, you can go to the school. There's a box in the office, by the office, that has a copy of this sheet, two sides to it. Also, I have on the blog another step-by-step instruction how to develop the linear regression equation or any kind of regression equation you do later on. Also on the blog, I've given instruction on how to use your Desmos to develop the linear regression equation. The next lesson, we'll look at example 2. But I would like you to try out, if you go into your booklet, what we've done today, just complete this one question here in the regression. And if you're having no problems with that one, try example question 2. But for now, I want you to attempt question 1 to determine the linear regression equation from this set of data and use the regression equation to predict the depth of a lake that is an area of 43,000 square kilometers. So quick overview. Today our lesson was about using technology to display data and find a linear regression. We used the graphing calculator. For step 1, we sketch the line of best fit for the set of data on the graph. Then we use our graphing calculator to determine the linear regression equation that models the situation here. And we found out what it is. Then we were asked a couple of questions regarding the price of a house of a certain size. We have 2,000 square feet and 3,000 square feet. And we went through a set of instructions on your calculator and how to arrive at the linear regression equation and also find the y value when x value is given. Those instructions on how to create linear regression are on page 13. And also on your handout on calculating instructions for applied 30S. Your assignment is to attempt question 1, assignment 3. And if you have no challenges with that one, you can attempt question 2.